Web streaming. Anybody there? Okay, there's one person there. Who are you going to be? Hi, Margaret. Yeah, we're blowing up. Hello. All right. So this week, I'm James. Hi. This week, or was it last week? It was last week. Here at Manifold, we had a yes, Devin. I will be covering the differences between Kubernetes and Scrum. So last week we did a lunch and learn about Kubernetes and containers, and thought I'd just record it and have some fun with some silly commentary from the live chat as we do it. So also I get to play around with OBS, which I haven't done before. So we're going to do a quick little overview and then get some code running under Kubernetes and go from there. Yeah, a bit of echo. It's a pretty big room, so it's actually echoing in the room as well. Once we get into the coding section, get the chat up here so it doesn't seem like I'm just talking to myself, which I will do, but right now I'm actually replying to the chat. So, hello, Kubernetes and containers. It was interesting for me because I think that some of the audience in our company actually more interested in learning more about containers to start with. So hopefully anyone who's watching this might be able to learn some more just about some of the groundwork here before we even get into Kubernetes. But we'll cover both. So we're going to go over real quick what a container is, what Kubernetes is, why it's neat versus some of the other things that we've had before, and then we'll play with it. So, what is a container? I started this slide with a bunch of text, but I think a visual representation works better. So we started with just doing deploys right on bare metal systems. So you think of the cracker is a piece of hardware, right? That's your server. And then the cheese is the operating system. And then on top we have a jalapeno or jalapeno, your application. So we started with bare metal, one machine, one operating system, one application. You could pack more applications in there, but to get nice isolation, you need the full snack. Then we got virtual machines. So with virtual machines, we take our operating system and we put operating systems on top of it in virtual machines and then run the applications inside those. If you can see, the cheese on the left here is actually a different kind of cheese. So you could run different operating systems within your virtual machines. And now we've moved on to containers. So again, we have our base operating system, we have our base hardware, our base operating system, and then we put on a delicious Bacon container engine and run the applications on top of that. So you can see, just like the bacon here is thinner than a full operating system. This holds true, or sorry, a full cheese operating system. This holds true for containers as well, which is very nice, right? So there's less overhead per application while still getting some nice isolation properties. So that's not all there is to it, right? There's a big ecosystem around actually building and deploying your code in containers. So your container is the code as it runs on the system. The container image is your code like packaged up in a bunch of tarballs, basically, and extra metadata describing how to put those together, and environment variables you might need, network ports you expose. So not only does it say like what the code is, but it gives some information about how to run it too. And then the sort of the icing on the cake is the concept of registries, where we are able to store all of our different container images. So like Docker Hub would be the canonical example, where you can just go and fetch images that other people have built and to build on top of it. Take like a base Alpine Linux image and then run your code on top of that. So I've been trying deliberately to not say Docker so much, but say container, because Docker is not the only container system that we have. And as time goes on, you may touch Docker less and less when you're using containers. So I built this little logo splash here, but it's actually a nice family tree. So we've got our Open Container Initiative, which is working on defining standards for containers, image formats, specifying how the runtime works and everything. Moby project is the open source version of Docker. There was sort of a recent split, making Docker into the commercial entity that sort of heads the project, and also the commercial project or product offering. RKT from CoreOS folks, and the other one over here is the Clear Linux logo, and this one's kind of interesting. So this is Clear containers, are able to run on OCI images, and that's cool because it's just a lightweight virtual machine. So you can go from container stuff, like which would traditionally use namespace and resource isolation within the Linux kernel, and instead use the same stuff to run inside very lightweight virtual machines. So now we're all experts on containers. Let's talk about Kubernetes. So Kubernetes provides cluster or container orchestration. I mean, cluster in the sense of all of your sort of big computer hardware things, but containers sort of what may be more accurate because it does focus right on containers. But you run or orchestrate a bunch of programs and containers on a bunch of computers. The number of programs you run is not tied in any way to the number of computers you have. And it lets you treat all the computers you have as sort of one system. You can point commands at your Kubernetes cluster, and it doesn't really matter to you necessarily like what system executes it or where your code runs, although you can specify some of those things if you wish to. Excuse me. So Kubernetes is like super popular. Right? If you look at the Google Trends for it, it's a big hockey stick. And I think part of this is because of the way that Kubernetes is modular and extensible. It's very easy to build layers on top and take the core concepts and add things on top and on top and on top of that. And that's sort of how Kubernetes itself works. You start with, a container image, and you take one or more of them and put it inside a pod, and then you take pods and you put them in replica sets, and it builds up from there. So you can do the same thing as you extend Kubernetes yourself. So it's super neat. Some of the things that I have found nicer in Kubernetes versus doing things by hand or using Mesos and Marathon, is that you get a lot more things out of the box, and it's not just sort of a particularly opinionated workflow, but it just sort of handles all of these pieces and lets you put them together how you want. So rolling deployments out of the box, really nice integrations with external DNS setups, so you can sort of just deploy some container, and if you've got other bits configured right, boom, it's got its own host name set up. And a very big thing is the prevention of configuration skew. So if you had an old system, that you're running and you're using Chef or Puppet to manage configuration for it, it would be very easy to get some kind of configuration skew where during an outage or some kind of catastrophic event, someone has to just SSH into a machine and they quickly edit a configuration file and restart the service and fix the problem. But they forget to check that into source control, where you keep your Chef recipes. So over time, the state of your system skews away from the representation you have in your configuration management. With Kubernetes, you do all of this stuff by sort of applying these manifests to the entire cluster. And Kubernetes works very hard to continually look at these and make sure that what has been described is what is actually reflected and running in the cluster. So things like a replica set, where I say, I want to run 10 copies of this pod. If someone goes in and shuts down one of those pods, Kubernetes will notice and bring up a 10th one. So it's keeping the state of the running system as close to what you've asked for as possible is a very nice property. So a quick little detour about how to speak Kubernetes. You may not need this if you're watching, but maybe you do, and it's kind of fun anyways, right? So it's the thing that hangs up some people is the whole putting numbers inside words thing, and it's just kind of common in computer stuff, but you take the number of letters you have in the middle and count them and squish it down. Cube, without being inside Kubernetes, is commonly pronounced cube instead of kube, but it can also be kube or kubi. CTL, ADM, control, and admin. And that's kube cuddle over on the side there, which is pretty fun. All right, so let's use it. Let's see if my scene transition works okay. I'm just going to fiddle around with my camera for a second here, and then we'll be back. Cool. Oh, wait. There we go. We'll fix it in post. All right. So I've got VS Code here. I thought it would show up better on the screen. But I'm by no means, this is the first time I've ever used it, so bear with me, and I'll be using the mouse a lot for it. So I'll just get rid of that, and get rid of that. We'll start with master here. So I've got a, oh, I should start by actually showing what we have running is Minikube. So you can check this out and get it running yourself and just to start, and I use the Xlib driver here since I'm on macOS. But yeah, now you can actually see the cool chat over on the side here as we go. Anyway, so we can do Minikube dashboard and actually bring up the Kubernetes dashboard that's running in the virtual machine on my laptop here. So you can browse around and check out all the different stuff. I don't have anything running yet though, so not much to see here. So let's check out the code we have here. So, right, just a simple a Node application using Next.js. It's going to be hard to break the Vim habit here for this. So just a basic Node app here. I guess we could actually probably do yarn dev to check it out. But let's start by writing a Docker file for it. So first, see, bad habit. Well, great habit, but not for this stream. So we will start by writing a Docker file. So Docker file is a way to describe the building the container you're going to use, and sort of the runtime parameters for it. So we'll start by doing setting up the well, I'll start by opening a little window in another location here, so I can cheat a little bit on it. But anyways, the first thing you need to do is describe the sort of your base layer, where you're going to start from. Because we're going to need something to base it off, and that can actually just be like nothing, so you could say from scratch. But for us, we're going to start with, I got it right, Alpine. And then we want to take our code and copy it somewhere into the build context that we'll be working in. And just for convenience sake, we can say we're going to keep working in that. So from the README, we had our steps here for running the production grade version. So we build it, which will pre-compile some of the Next.js assets, and then start it to run it. Sorry, don't want to build yet, but I do want to use yarn to install the dependencies and then do yarn build. I'll do that in a single command here, a single step. So that'll actually make a single Docker layer for it. Now there's newer versions of Docker will let you sort of build steps and then compress them together, but that's not the case with the one that ships with Kubernetes. So it's a web server, so we want to expose port 80. You could use another port, but it's HTTP, so let's stick with the standard one. And then we can set some environment variables to expose here too. So we'll say we're going to give the node process an environment variable as well. And I'll choose more. And then we just give the command that we're going to run. So return start. Assume that's saved. Let's see. Nope. Did that save? It did. Hey. Okay, so we need to set Docker up to talk to Minikube. So Minikube, Docker, and I'll set the environment variables we need. Docker build -t. So we're going to tell Docker build the stuff in this directory and then give it the tag of bay. So usually you'd want to append like you'd include not just the name here, but also a version, so you can like pin your code. But this is okay for us for now. So it'll go through and pull down dependencies for this Docker layer, and then start running our steps that we've defined. So move our code in. And filter packages. And we're almost done. We're almost done. All right. So this has built the Docker container image inside the virtual machine that's going to run Kubernetes for us. Now what you'd usually do is push it up to a registry and sort of deploy from that registry, but since we already have the image inside our Kubernetes system, we'll just use it right from there. So what do we do next? Well, we can start running this. So I'm just going to reset here. So this branch now has some, I guess I can just go to the README here, and maybe it auto-loaded for us. Yeah, it did. Cool. So we've got some commands to run here. So let's give them a run and see what happens. Okay, so so we've created a Kubernetes namespace here to run our code in. Just a nice way to organize stuff. Let me go back to the. Yeah, cool. Right, so now I've got this bay namespace here. So my stuff over here, and it's just the default stuff in default. And then of course there's this system level namespace as well for actual components of Kubernetes that run inside Kubernetes. I'm sorry, scrolling like that is probably terrible on the stream. So I've created a namespace, and we're just doing a quick way to run deployment, just using the command line here. So we're putting it in the namespace, and we're using that image we made. We're just telling, like, don't ever bother pulling this because you won't find it in a registry. And we're calling the deployment bay. We're going to expose that deployment. So we're actually making this service, and the service is like a concept, a way to group these pods into a single sort of. It's kind of like an internal load balancer. But we're also so that you can address them within Kubernetes. But we're also exposing this externally. So we're doing this node port thing, which will give the service a port on the node, like the worker node in Kubernetes that it's running on. And then we can use Minikube to actually access it. So if we say service, and we're saying we're in the bay namespace, and then we'll just do bay, and there we go. We got our really cool app up and running inside Minikube. Yeah. So it's just showing the environment variables that we have access to. There's some neat stuff in here besides the node stuff. You can see like configurations for Kubernetes if you want to, if your code is going to actually call the Kubernetes APIs, know where to go. There's some other sort of service discovery environment variables. So you'll see like the address for the bay service itself. So this is like if this code wanted to speak to itself, but there would be others. If you had other services in your cluster, you could find them that way. What's this one to show? So we can use kube control to actually view some of the stuff here. So we can look at our deploy. Describe. You can see some cool info about it. Yeah. So this event stuff. Most of this information is mirrored in the dashboard as well. We came back over today. You can see our deployment here. And the events and everything for it. See if there's any So a bit about concepts that we have up here in Kubernetes. Let's go back to the overview. All right, so you start with your image container, or sorry, your container really running on the system. One or more containers can run within a pod. So a pod is just sort of a grouping of containers that will always run together in the same namespace. So they sort of have privileged access to one another. We take pods, which you could equate to a virtual machine, or in other systems, like a container actually. We take pods and put them into replica sets. And replica sets just ensure that there's the specified number of pods always running and healthy at the same time. And then replica sets are managed by deployments. And deployments take care of, based on configuration that you've set, they take care of scaling in and out replica sets as you do a new deploy. So if we had defined a deployment with version 2 and then updated it to version 3, it would make a new replica set for version 3 and start scaling that up as it scaled the version 2 one down. And then we have services, which are how you can expose these, all the group pods in your replica set sort of as a logical group to the outside world. But all of this grouping and association typically happens through labels. So you just sort of tag your stuff with labels, and it gets grouped that way. So if we look at, there I go, over here. So if we get the Bay replica set, that is probably what's it called? Yeah, right, because it comes from a deploy, so it's got a sort of unique value after, or a unique suffix on it. Yeah. Give you the animal that where are we looking for here? So yeah, so you can see these sort of selectors here. So selectors and how Kubernetes sort of groups things together using labels, matching labels against the selectors. Cool. So let's move on. What we've done so far is just define or sort of run things imperatively, but the Kubernetes is all about declaratively describing your system, your configuration of it. So instead of saying, well, hey, run this right now, you want to say, I'm going to define this deployment. And if it's already running, great. If it's not, we don't get it to run. Because if we ran that, conceivably, if we ran the run command, it would just make a new deployment. So let's just go right to getting the YAML that we're going to use for this. Time's sort of running on. So we've got a directory here of a bunch of YAML files. So these are manifests for Kubernetes. So if I edit one of them, this one's actually pretty simple. I don't need to read this right well. Just a simple YAML file to define the namespace, our Bay namespace. But we can do the deploy one would be more interesting. Deploy, this is what the run command achieved. So we're saying, we'll group it with this run label. This is just to match what was there already. Name Bay in the Bay namespace. I'm going to have one replica. And, describe the container we want to use. So what we can do is kubectl apply. We can say the file, and we can just give it the whole directory. And this will take all of these YAML manifests and just run them all. And the namespace one has 00 in front, so that we kind of ensure that it runs first, since everything else needs the namespace before it's created. So we can run that. And this is actually sort of replacing some of the other stuff. So depending on how you've defined it, like in doing what I've done here, it's actually going to shut down some of the stuff and recreate it, but you could sort of gracefully inherit your YAML manifest like onto something actually running. But we're not going to have duplicates of it now. And I can just safely like reapply all the time and everything will be a-okay. So if I sort of check that out again. So you can see like the service port changed here because of rebuilding the definitions. But anyways, everything's still running. I think it is actually only the service that had an issue here. Let's see. Fine. Anyways. So, what else can we do? We can modify our deployment. So let's edit our deploy and add some configuration to it. So we'll set an environment variable. Probably not going to get the syntax right, but that's okay. And oh, look, I did it in Vim. That's all right. Kind of silly to be using Vim inside VS Code. So if we apply that, see what it says. Oh, okay. Type and map expected array. We've got that file. Yeah, let's just use that. Do we just want? Yeah, that's what it wants, I bet. Cool. Check it out in Google Chrome. So we've got our test configuration value with high. So this, if we look into our deployments, we can see what happens here is that a new replica set was deployed with the new setting. So age of 24 seconds this is the new one holding the new configuration values. But if we did something instead, like in here, we could change the replica value to 3. Apply that. You can see it's scaled that new one up to, so there's just an old one that's like, scaled down and gone. It'll get garbage collected later. But it just scaled that existing one up to 3 instead of making a new one with the new values. So we can just look at that and see our new replica set. We just scaled it up. Oh, sorry, let's see previous down here. Cool. So something else that we could do, let's look at branch here, get a little preview. Go into this one. So we've had a config or set an environment variable. Let's use config maps. So config maps are a way to take that configuration that I did with environment variables and abstract it out from the deploy, so that you are able to take your, one reason is you can take your deploy specification and reuse it across the different clusters and have the config sort of be defined externally and have whatever is there in that different cluster be used in your deploy. You can also sort of separate responsibility out for it. So if it was something like a debug flag or whatever, you could have it set by different teams in different environments, and in production you might want to have it set to off or whatever. So if we look at here, we can see our config map. So there it is, config. So it's pretty simple. We really just define data that we're going to store. So we've got an environment or a key value pair for it. And then we can take this, and I guess this should be reloaded. Yeah, so we can take this and say we'll get our environment variable from this config map reference, and we're going to use the bay config map. So if we apply all this, I'll set here. All good. Go to Google Chrome. Those. We've got our new configuration variable brought in from a config map. All right. Let's go back to the slides for a bit. And finish up. Just a second. Figure out where I need to be, and you listen to me mumble a little bit. Cool. So some other stuff you might want to check out next inside Kubernetes. Ingress. So the concept of ingress in Kubernetes is very neat. Ingress is in getting in, so how you get network traffic into your cluster. There's a very nice setup for exposing different sort of virtual hosts or paths to services within your cluster, and it'll connect to sort of whatever is natively available in wherever you're running your cluster. So that might be ELBs under AWS, or you might have it set up for like Nginx if you're running on bare metal, etc. Service discovery, so I touched briefly on it, just the environment variables that got exposed for telling you about other services running in the cluster. There's also a very sort of extensive DNS that gets configured for all of your different hosts and services, and nice routing for those. Stateful sets are similar to deploys, but they handle code that needs some kind of state, or persistence to it. So it's a way that you can map storage volumes into your pods and have the volume sort of reassociate with the correct pods when things go down and come back up again. Daemon sets are a way to run like a single instance of every pod on every node. If you asked for, if you naively asked to run, say, if you had 10 nodes and you ran 10 replicas, there's no guarantee that you would get one per node. And if you lost one of your nodes, you wouldn't want to have like 2 copies of this code running on one of the other nodes, right? You want it to be exactly match the number of nodes you have. So daemon sets will accomplish that for you. That's good for agents for monitoring your system or what have you. And resource limits. Compared to other systems I've used, resource limits are like how you specify these are in Kubernetes is very nice. You can set sort of what the system or what your code needs, like absolutely, and what it would prefer. And so you can sort of get some kinds of SLA there. And Kubernetes is able to use this info about like how much CPU or RAM you need and schedule your code appropriately to sort of pack things in nice and tight on various nodes in the system, or either sort of throttle their usage when it is starting to get too high so it doesn't affect other code running on the same node, or in the case of memory usage, just sort of like outright kill the process off. Oh, well, I mean, that's a wrap up. So thank you so much for tuning in or watching this later. And hopefully we'll see you again. Thank you. Bye-bye.